In this next series of slide cards, we're going to look at quality. As you can see by this little cartoon, quality means different things to different people. So quality in engineering or civil engineering is conformance to the project requirements and fitness for purpose. In other words, it does what it's supposed to do. So when you're looking at a final product or a component or something, you're saying, does this do what it was originally intended to do? So let's look at each one of those in a little bit more detail. Project requirements, those are the project needs identified at the start of the project. So if you're talking about a design project, you're talking about the needs that were the requirements that the client set at the beginning of the project. He might have said, I want a building to an office building to house 100 people. I want it to look attractive. I want it to have low maintenance. I want it to have good insulation so that I don't have to spend lots of money on electricity. So those are what they mean by the requirements. Now in a construction project, the project requirements are really simple to find out. They are in the tender document. And specifically, they are in the specifications and the drawings to show exactly what you're supposed to build. Fitness for purpose is do the project works do what the client wanted them to do. Now hopefully, if you're looking at a construction project, the construction project will do what the client wanted it to do, but sometimes that's not the case. So those two things, project requirements and fitness for purpose, are two different things. And that's shown by this graph here, by this table. So on the left hand side there we have the customer satisfied, is it fit for purpose? And on the bottom axis we've got, does it meet specifications, does it meet the project requirements? Now quality is when both exist, when it is fit for purpose and it meets the project requirements. Failure is when neither is met. Now there's these other two corners there on the diagonals where the customer is satisfied but it doesn't meet requirements, and the customer is not satisfied and it does meet requirements. So where the customer is satisfied and it doesn't meet requirements, you need to look at the specifications. It might have been that you built what the client wanted, but you didn't specify it right. So when you're preparing the specifications, if it's a construction project, it might have been that you made a mistake, that you didn't translate the client's requirements into the specifications for the work. Specifications, remember, are the documents, and usually in a tender document, that say these are the quality standards that need to be met. And if you've got, and it may be that you build it to the contract document or the tender document, or if you're talking about design, you might have designed it to the requirements of your consultancy contract, but the client's still not happy. In other words, you didn't translate the client's needs into the scope of your project. You didn't find out exactly what the client needed before you started the work. And that's why it's very important right at the beginning of a project, during those initial stages, that you determine exactly what the client wants. You don't make assumptions. You determine what the client wants and you write it down and you get him to confirm it, to avoid this quality failure here. So looking at that meet specifications again, you can see this example here where there's the client specification is obviously, I want a sign that tells people to give way, and the one on the left is correct because it's nice and simple, says give way. The one on the right still tells customers, motorists, to slow down and give way, but it does it in a way that is very hard to understand. So in this case, the project specifications were not just to provide a sign to tell motorists to give way. It was that the sign should also be very quick and easy to understand and read. And you can see that the one on the right fails that requirement quite significantly. The one on the left doesn't. Now, it seems like a bit of a silly example, but in engineering all the time you overcook what's required. You know, simplicity is good in engineering, and in this case they found um, a simple good answer in a sign. And the one on the right, they just sort of took the client's requirement, built me a sign that tells people to slow down, and didn't give it much thought. And fitness for purpose is the project works do what they're supposed to do. No more, no less. If you do more than was required, it's going to cost extra. If you do less, then it's not going to meet the requirements. So that's what fit for purpose is. So that concludes these definitions. The next one we're going to look at how we apply this to a civil engineering contract.